Yo, what's up? In this video, we're going to cover note 6.1. I'm also pretty unsure if I'm going to be able to have copies for y'all in my classroom because I just don't know if I'm going to be able to do that for y'all, basically. So you can either follow along on a separate sheet of paper, or if I do happen to find some way to get copies there, then you should be able to get them from the sub or whatever. Okay, anyways, let's do this thing. So today it's going to be about adding and subtracting polynomials, and I think it won't be that bad, but I guess we'll find out. So here's some vocab. Basically, a polynomial is just poly means like a lot, and nomial just means like the terms. So each term is just separated by like an addition or subtraction sign. So this one has three terms. And what a monomial is, it's just basically one of these terms. Okay? So whenever we are writing polynomials, there's a couple things that you should do. Just it's just like tradition basically to do it like this. It just makes things look nicer, and that's to write the monomials in alphabetical order. So you won't be writing things like you know oh my gosh, you won't be writing things like z y x. Instead, you would write it as like x y z, just so they're in alphabetical order. Also, the polynomials, just in general, you're going to write them from the biggest power to the smallest power. So that's what the degree is. The degree is just basically the highest power. Putting the terms with the highest degree first. Sorry, I know my tablet's kind of small, so my handwriting might not be the best, as per usual. So for example, here we have this trinomial, this polynomial, and we're going to rewrite this like this. We're going to put the x cubed first because that's the biggest power. So 2x cubed, and then plus the 15x, and then minus 3. Okay, so for polynomials, and you'll even see it up here. When we talk about the degree of a polynomial, this just means the highest power. So the highest power in our polynomial is 3. And then the leading coefficient just means the number next to the variable with the highest power. So the leading coefficient of this would be 2. Okay, so for adding polynomials, just like it says here, this one's already worked out for us. You just have to combine the like terms. So you have to make sure that the variable is the same and that also the exponent is the same. So right here we have an x cubed here. And we're going to look at our other polynomial, and it looks like we also have 1x cubed here. So then we're going to combine them. We have 2x cubed and then 1x cubed, so that's why it's going to have 3x cubed in the final answer. And then you're just going to do that for the rest of them. So we have negative 5x squared here, and then you have 2x squared here, so that's minus 5 plus 2, that's negative 3. And then we have an x here, but there's no x in the second one, so our x just stays to be x. Negative 7 and negative 1. If you add those together, and you get negative 8. This is a really good point, is that you want to make sure that the exponents don't change. A lot of students, what they would do is they would like say 2x cubed plus x cubed, and they would say that that's like 3x to the 6. They would add the 3 and the 3 together, and that is not what you want to do. So just make sure you're not changing the exponents. Okay, so we just have a few examples here. So what you should do is you should try to do these on your own first, and then take a look at what I do afterward. So you can, pause the video and try them on your own first. Okay, So hopefully by now you have done the examples yourself, and now you're going to watch me also do them, hopefully correctly. So if we take a look at the first one, we have 5x cubed. So we're going to look and see if we have any x cubes in the second polynomial. And we do. We have an x cubed here. So we're going to add them. 5 plus 3, and that's 8x cubed. Notice how I didn't change the power, the exponent. Okay, and then now this is kind of interesting because what I'm going to do is I'm going to look for any x squareds. I'm just going to go down in the exponent. So I started with 3. That was the highest one. And I'm going to look for any x squareds. And I do have an x squared over here. So here's an x squared. And there's no x squared in the first one, so we're not going to have to combine it with anything. So this first one, we're just going to have plus 4x squared. And now we're going to look for any x to the first, and we have 2 of them here that are actually in the same polynomial. So we're just going to have to combine these two. 4x minus 2x, that is positive 2x. And then lastly, we're going to look for any constants. Looks like we just have a -6 here, so we'll just have -6. So you should have an answer like this: 8x cubed plus 4x squared plus 2x minus 6. So notice how I wrote my polynomial in descending powers. Okay, the second one's a bit more interesting because we now have some crazier monomials in the sense that we have u's and v's. But it's pretty much the same thing. You just have to make sure that the variables and exponents are the same. And if they are, then you can combine them. And if they aren't, then you can't combine them. So notice the two that I've underlined here, they have the same exact variables, u to the third and then v to the fourth. So I can combine those. So that'll be -5 minus 5, that's -10. And then remember, you're not going to change any of the exponents. So u to the third, v to the fourth. Now we're just going to look for anything else here. It looks like actually I kind of made a small error, and that's fine, because we actually have another one that is u to the third and v to the fourth. So we have -10 here, and then we have to add 8 more. So I am going to make this a -2 instead. Okay, and now we're going to look for other things. So we have u squared v squared here, and it doesn't look like we have anything else with that. So I'm just going to write this one down next. 8u squared v squared. And then it looks like we have u by itself. So 9u minus 8u, that is plus u. Okay, so now we're going to move on to subtracting polynomials. And it's pretty much the same thing, except that it is subtracting. You just subtract instead of add. Pretty crazy, am I right? So take a look at this example. The key thing is about subtraction is that you need to distribute the negative. Okay, so here we have this first polynomial minus the second polynomial. And if you take a look at the red, what this person did is they distributed the negative to all 3 of these. See how this positive 2y squared became a negative, this positive 2xy became a negative, and this -3 became a positive. After that, you just have to combine the like terms. So let's go ahead and do this first one. So the first thing I'm going to do is I'm going to distribute this negative. So we'll have, here, I'll even write this in black first, 5k plus 4. And then we'll have a minus, because we are distributing the negative, minus 5k minus 3. So now we can combine like terms. 5k minus 5k, that's 0. So that's going to actually just cancel out. 4 minus 3 is 1. So there is our answer. All right, and here's the next one. So for these other two, go ahead and try these on your own first. Remember to distribute any negatives, and then just combine like terms. Okay, so hopefully by now you have done them, and we're just going to see if we get the same answer. So I'm going to distribute the negative here. And we will have 4n minus 3n squared. And then after distributing the negative, we will have a minus 3n squared minus 4n. Okay, so now let's go ahead and let's combine like terms. So negative 3n squared and negative 3n squared, that will make negative 6n squared. 4n minus 4n, that actually cancels out. So we are just left with this, negative 6n squared. Okay, and this last one, it just looks scary, but it's the same exact thing. We're just going to distribute the negative for both of these with the subtraction sign. So we'll have this here, and then we'll have to distribute the negative here as well. So let's go ahead and rewrite all of this, but with the proper signs. So this one's going to stay the same. And then these two, we're going to have to distribute the negative 4. So this will become a positive 6x squared, a positive 7x cubed, and a y squared also, plus 4x minus 10x minus 9x squared. All right. So let's combine like terms. So first, let's go ahead and do these monster looking ones, the x cubed y squareds. Those are the same, so we can combine those. So we will have, it looks like 14 x cubed y squareds. And then let's go ahead and combine the x squared next, because that's kind of the next biggest one. So it looks like we have 4x squared here, 6x squared here, and minus 9x squared here. So that's going to be 4 plus 6, which is 10, minus 9, which is 1. So we're actually just going to have plus x squared. And then lastly, it looks like all we have left are these x's. So let's go ahead and deal with that. We have a 4x minus a 10x, so that's going to be minus 6x. Okay, so lastly, we have this application problem. And this is just a perimeter problem. Basically, all you have to do is just add up all the sides. Remember, perimeter, that's what that is. Whoa, that is too long. Perimeter, you just are going to add up. Okay, I'm confused why that's doing that. But you're just going to add up all the sides. So trippy. You're just going to add up all the sides and see what you get. So how many n squareds do we have? Looks like we have 4n squared here, 2n squared here, and 1n squared here. So I'm going to do this, undo this. Hopefully that will fix it. We'll have 7n squared. And then we have a negative 5n and a 3n. So we'll have negative 2n. And then we have 6 minus 2, which is going to be 4. All right, so that's going to be it for this video. And I will see you in the next one. Okay, bye.